I have a problem in my ham shack. You see, these lights are powered by 12 volts. Not 12.5, not 13.8, 12 volts. So I have this power supply here, it's a variable power supply, that's running this, that's connected to this power pole distribution block here. The problem is, while it's great lighting for filming and doing projects, whenever I want to actually use 13.8 volts for radios or whatever, I can't use these, because if I turn this voltage up, the lights turn off. They don't break, but the lights turn off. And then I gotta bring it down to 12 volts, and then you got the remote, doesn't work, you gotta unplug them, plug them back in, then maybe that one works, then I gotta go over here, unplug this one, plug this back in, then they both work. So I need another variable power supply. And my friends at 12VoltPower were kind enough to hook us up with this Opek OP-PS3005D variable 9 to 15 volt power supply. We're gonna take a look at it this time on Ham Radio Tube. And this is what it looks like. We've got a 30 amp switching power supply. It's gonna operate off of either 110 or 220 with a switch in the back. You've got a 13.8 volt adjustment here. I don't know why it says fixed, because it's variable. And then we have a max current of 30 amps. Taking a look at the side, we've got some features on here. We've got a digital LCD meter that displays both the voltage and the current. Again, we have 120 volt or 220 volt, 50 or 60 hertz. Output voltage 9 to 15 volts. We've got a 28 amp continuous current rating and a 30 amp surge. We've got 2 Anderson power poles on the front, and we have some binding posts on the rear. Got a power cord socket and a temperature controlled cooling fan. There's a look at the back, but let's crack this guy open. And while we do, I'll tell you, you can head over to 12voltpower.com if you want to pick one of these up. They're currently going, at the time of filming, for $159.99. I'll leave a link in the description. We've got a nice user's manual here. 2-year limited warranty. That's fantastic. Some safety warnings, blah, blah, blah. Let's get into the power supply. Here's our power cord. Looks like a power cord. Nice packaging here. Some styrofoam there to keep it nice and safe during transit. Let's crack this guy open. Got some nice rubber feet on here. Here's our switch for the 115, 110, 120, whatever, or 220. It's all metal construction. Let's take a look at the front here. There's our 2 Anderson power poles. Got a nice LCD screen, on-off switch, and a variable voltage adjustment. There is a detent right there that should hopefully be right at 13.8 volts. And then taking a look at the back, there's our AC input. We've got a fan, and we have some binding posts. These will, so you can connect either presumably ring or fork terminals. Let's see, do these come off all the way? Hopefully they do. Yes, they do, so we can put some ring terminals on there. Or in the center here, you can actually plug in banana plugs if you want to do it that way. So let's take some measurements here. We're about 6.5 wide, 3 inches tall, and it is just shy of 8 inches deep. The housing to the button here were a little over 8.5 inches deep, so not very big at all. Let's go ahead and power this guy on. And looks like we got 13.8, 13.7 volts. It's on the detent right now. Minimum voltage, 8.1 volts it says. We'll test this here in a second. Let's go back up to the detent there. Getting 13.7, close enough to 13.8. Let's go all the way up to the top. Actually getting 15.3, 15.4 volts there. Let's go back to this detent, see what it does. 13.7, 13.8. Where will it stay? It stays at 13.8. So maybe if we go to the low side and come up, it goes back to 13.8. So that's good. My MFJ one, you gotta move it just to the right of the detent to get 13.8. So yeah, it's not perfect. It's not perfect. There on the detent, we're getting 13.7, but I don't know. Is that close enough for margin of error? We'll call it whatever you want to call it there in the comments. So voltage, then we've got our amps here. Let's go a little wide here, see what our meter says for these Anderson power pole voltages here. 13.85 there. So let's go, we're on the detent there, 13.7. Sometimes it goes 13.7, sometimes it goes 13.8. 13.79, I'm going to call that close enough. And 13.79, that's good. Let's go all the way down. 8.1, 8.1, let's go all the way up. 15.3, 15.43, oh, 15.4, it's kind of teetering there. And then back to 13.7, 13.8. That's showing 13.8, so that is pretty good. Now I've got the probes in the back outputs, so let's go down to the bottom, 8.1, 8.1, 13.8, 13.7, whatever. Close enough to 13.8 though. Wish it would just read 13.8. If you kind of just touch it a little to the right, maybe, will it work? I don't know. That's just my OCD. I wanted to say 13.8. So there we are, 13.8. And all the way up to the top, 15.3, 15.43. So we're reading a little bit low there versus what my highly calibrated Klein Tools multimeter says. So who knows which one is right. Good enough for our margin of error. So now I went ahead and brought the power supply over to my ham radio desk, and I have it connected to my ICOM 7610. Make sure we're on 13.8 volts there. Go ahead and turn on the radio. And I know my radio pulls about 2.5 amps. We're showing about 2.5 amps there. That's great. This waterfall here, that is a lot of RFI, but that is because of my studio light. And if I turn that off, there it goes away. So we're not seeing any RFI from the power supply, which is good. I am in a very high noise environment here at the house here. So on 20 meters, none of this looks out of the ordinary. Doesn't look like we're seeing any RFI coming from the power supply. This is just what my noise floor is at home. 40 meters looks okay, but I'll show you, I'll plug this into my other power supply here in a second. So that's what it looks like. I'm curious some of this noise though, if this is causing that interference. So let me plug this into my Yaesu power supply that's underneath the desk, and we'll take a look at the scope again. Okay, back on the Yaesu power supply. And yeah, we're seeing the same kind of noise there. So let's turn this off. Yeah, so this isn't causing any RFI. So that's fantastic. So now let's take a look at the current output and the power output. Here's our power meter right here. We also have it up there. I'm on 100% on CW on a clear frequency on 20 meters. We'll go ahead and key down with our beautiful J38 key, getting about 19.2 amps there. You can see the power meter is right at 100, so we're getting all the power we need. 19.3 amps, that's pretty much exactly what this radio does. So getting good readings, full power right out of the power pole, fantastic. So that's fantastic. You'll have no problem using this switching power supply with your radio, no RFI, does all the things you want it to do in terms of voltage and current. But now let me set this up for how I'm actually going to use this on my workbench. And we'll take a look at some practical uses there. And there's our 13.8 volts. So fantastic. We've got the new power supply set up exactly how I want. Now I have my lights on at 12 volts, and now I have the Opek powering at 13.8 volts, my whole power distribution box. So that's fantastic. So how do I actually use this? Well, before we get into that, I want to mention, per the manual, the protection. We've got overload protection, over temperature protection, short circuit protection by constant current circuitry, and output over voltage protection. That's a lot of protection. Am I right? And ironically, I turned the lights off for this shot so we can see the display. Here we've got a 12 amp hour Bio-NO battery. We can go ahead and plug this in. I would recommend a fuse in line, but I like to live dangerously. So we're pulling 7.5 amps there, 6 amps, probably fully charged. But we can bring this up to 14.6 volts to charge this battery. I don't recommend doing this, but you can, because I'm putting 14.5 volts or amps into a 12 amp hour battery. But if you wanted to charge your lithium iron phosphate battery off of this, you could. Again, don't recommend it, but you could. Now, one thing I did notice about this, there's literally nothing plugged into this. There's no load whatsoever. I mean, even the power pole distribution block, there's no parasitic load there. The fan does seem to be always on. At 13.8 volts, it's just a whisper. But we're also showing 0.1 amps there. It's not sitting at 0 with no load, so presumably it's accounting for the fan, maybe. But if we turn the voltage all the way down, listen to what happens. My mic might be able to pick it up. Here the fan kicks in just for a second, but if we go all the way up to 15 volts, the fan's just kind of on. It's quite noticeable. It's not loud, but it's definitely there. And 0.2 amps. So presumably it's pulling, the fan is pulling 12 volts, and we're seeing that on the readout there. So just something to know. But realistically, the actual practical applications that I use something like this for, I've got my power pole distribution block that everything's fused. I've got different size fuses on there. And I'll use this to plug in things like a radio. Say you want to test out a radio for whatever reason. Here's one of my 891s. Plug it in, whatever, do your tests, do your thing. You got 13.8 volts there. Life is good. Or maybe you got a QRP radio like my ICOM 705 or my Yaesu 818, or I think the Elecraft KX2 and KX3 now have circuitry built in to charge off of 12 volts. Well, we just plug this guy when we get home, back in. Light is red, we're charging 0.7 amps, doing the thing. Charging HTs is something I do a lot with this setup that I have here. So especially with the Yaesu radios, because they take forever to charge. Here's my FT5D. Go ahead and plug in the 12 volt there. Now we're charging, okay? Here's my VX7R. Plug that in there. Now charging. But wait, there's more. Because along with these Yaesu radios, I have my ICOM ID50 and then some other Chinese HT. I get these charging cradles. These are like the Chinese off-brand ones you get on Amazon. They're not like the Yaesu or ICOM ones, but they charge your batteries a lot faster. They use the same plugs. So FT5D with 12 volts takes forever to charge. With this little charger here, takes less. So we can see the light is red there. We're charging. This battery's pretty good and dead. We can plug in our other charger here for the VX7R. The light is green. Go ahead and plug that in. Now we're charging, the light is red. So just faster ways to charge your HTs. So now I've got both my Yaesu chargers, my FT5 and my VX7, connected to the front power poles of the Opek. That's freaking sweet, so I can charge those whenever I want and not tie up the Anderson power pole distribution block. Perfect setup. But sometimes we need a voltage other than 13.8 volts. And that's where having a variable voltage power supply comes in play. Case in point, my label maker. I'm a ham. We got to put our call sign on everything, right? Well, this guy takes either a whole bunch of AAA batteries that it eats through, or it runs off a 9 volt DC. So I got a little coaxial plug. Oddly enough, the outer shield of this is the positive, but we got power poles. So I just have to remember when I plug this in, first bring the voltage down to 9 volts or close enough. I'm at 9.1. And then, this is gonna sound crazy, but we're gonna go red to black and black to red. And now my label maker's on. So I can print my call sign and put stickers on everything, just like we all do because we're hams. See, look, I'll even print something here. It's printing. It's printing. It's printing. It's done. Oh, look, what's it say? It says subscribe. So there we have it. That's a look at the Opek OP-PS3005D, a great addition to my shack. And if you head over to 12VoltPower, it can be a great addition to your shack as well. My name is Mike K. Marty. Thanks so much for watching Ham Radio Tube. We'll see you next time. 73.